From ice fire to chicken genetics, as part of History 2000 on BBC Two Wales, Adam Hart-Davis visits Yorkshire, hunting out more local heroes.
Hello and welcome to Local Heroes from Whitby. This week, all my heroes come from Yorkshire. It's hard to imagine now, but in the 19th century, catching whales was a major industry. Their blubber was used and the oil in lamps and so on. And the centre of the whaling industry was right here in Whitby. The greatest whaler of all time was William Scoresby, and these whale bones were put up to commemorate him. But I want to tell you about his son, a man who made magnets with a hammer and fire from the ice. His name also was William Scoresby. William Scoresby Jr. was born in Cropton, 20 miles inland, but the family moved to Whitby to live near their work. When he was only 10 years old, young William went off with his dad on his first voyage to the frozen north. When they were stuck in the ice, Scoresby used various tricks to amuse his sailors. One of them was to make fire from the ice. He would take a lump of ice from an iceberg and he would fashion it into a lens like this. And then he would use the lens and the rays of the sun to light his sailors' pipes. At least that's what he said. I'm not sure I believe him, but I'm going to have a go to light this, which is actually a bit of touch paper and some matches. So I'm going to hold this and focus the sun's rays as well as I can on that touch paper. Now, it's not a brilliant lens, so it's hard to tell exactly what's in focus. I measured the temperature and it went up from a freezing 2 degrees to about 20, so it works, but not brilliantly. The sun's not very bright here in Whitby, but then I can't believe it would have been much brighter off Greenland. I wonder if he really did it or if he just made it up. Now, can you do it? Do you think you can do it? The way I made this lens was to take a balti dish like this, and I took a great chunk of ice and I cut it roughly to fit in here, put it in the dish, and then warmed it very, very gently, and just kept moving it around until it just fitted the dish. And then we've got a nice lens shape as a result of the shape of the dish. Do that on both sides and you've got a double lens. So why don't you try it? See if you can make fire from the ice. I'll feature your best efforts in the final programme of the series. Details of where to send the evidence at the end of the programme. In 1807, Scoresby volunteered to do a job for the Navy in Portsmouth. And on the way back, he ran into Sir Joseph Banks, the President of the Royal Society. Now, Banks had sailed all the way around the world with Captain Cook, who must have been a great hero of Scoresby's. And so they had something in common. And Banks encouraged Scoresby to make scientific observations of the Arctic, which he knew so well. Scoresby made thousands of meteorological measurements. He wrote to Banks about the state of the Greenland ice and measured the temperature of the Arctic Ocean. He examined snowflakes using a microscope and drew stunning pictures of them, showing the hexagonal shapes that we know so well as a result of his work. He was a superb naturalist and observer of Arctic wildlife, including wonderful sketches of the whales he hunted. And in his journals he described and illustrated terrifying incidents in the life of an Arctic whaler. Not surprisingly, he was interested in magnets and compasses, and one year in Greenland worked out how to make a really powerful magnet using a hammer. Here's how Scoresby says he made his Greenland magnet. First of all, he took a piece of iron that wasn't magnetised. I'm just using a 6-inch nail. And to check it wasn't magnetised, he held it to a compass needle. And if you look carefully, you'll see that the end of the compass needle is attracted by the blunt end, and it's also attracted by the pointed end. So, both ends of the nail attract the compass needle. What Scoresby then did was to hold it upright like this and simply bash it with a hammer. And the point of this is that the Earth itself is a giant magnet with lines of force running from one pole to the other, which is why the compass needle points north. So, as Scoresby bashed the iron with a hammer, the iron atoms got shaken up and then realigned themselves to the magnetic field. I'll hold the blunt end to the needle and it attracts the red needle. Now I'll hold the pointed end and look, it repels it. It drives it right away around and attracts the white end. So I have turned this nail into a magnet. With the help of the ship's blacksmith, he kept on bashing until he had made the Greenland magnet. And it's still in the museum at Whitby. And this is the magnet he made. And he claims he made this in 2 hours just by hammering. And that keeper is still held with fantastic strength. I reckon this magnet must weigh about 10 kilograms, and it might even take its own weight. So let's put it to the test. It's 180 years old, and look at that. In between voyages, the Scoresbys lived right here by the harbour in what's become the Magpie Cafe. Whitby has always been a fishing town, and I haven't found better fish and chips anywhere else in the country. And what really appeals to me is the thought that I'm going to have my lunch exactly where William Scoresby had his, well, I guess they were whale steaks, probably. William Scoresby was a remarkable man. He was intensely religious. He wouldn't do any fishing on Sundays, and he banned his men from swearing because he said it would reduce the whale catch. Indeed, he went on to become vicar of Bradford. Now, lots of my heroes have fine memorials, and his is embodied in beer, Scoresby Stout, brewed specially in memory of William Scoresby Jr. Cheers. I think he would have approved. My next hero was born while his family were on holiday here in Whitby. He was one of the few people who can claim to have invented a new science, literally because he invented the word genetics. He defended genetics with religious zeal and got so unpopular that he found it very difficult to earn a living from his science. And yet, his work revolutionized our understanding of the way characteristics are passed on from one generation to another. He was William Bateson. William was sent to Rugby School. He loved natural history, but was only allowed to study the classics. He hated it, and no one liked him much either. But luckily for William, zoology had just been introduced at Cambridge. He was interested in poultry, so I've come to visit Jack Keeley, one of the top poultry breeders in the country. People like Jack had been producing new breeds for years. But it was all done by trial and error, and no one really understood what was going on. Bateson realised that nobody had a clue how heredity worked, and that was a problem that really had to be sorted out. Darwin and most other biologists thought that variation was continuous. That is, you could have very, very short people and very, very tall people and every sort of height of people in between. But Bateson looked at nature. He went to Russia to gather samples and also to Egypt, and he talked to plant and animal breeders and shepherds and gardeners, and he discovered it wasn't like that at all. It wasn't continuous. Variation happened in chunks. Everyone thought that when a male and a female mate, their characteristics somehow get mixed. Well, it seems to happen in humans anyway. But what Bateson realised was that if you look at one single characteristic, like the comb, for example, in practice, it never gets mixed. This is a single comb. This, a pea comb. If you breed them together, you don't get something in between, but either pea or single. But if the offspring have pea and single parents, what determines which one they look like? On the 8th of April 1900, Bateson read a paper sent to him by a colleague that changed everything. Incredibly, it had been written by an unknown Austrian monk, Gregor Mendel. It had been published 35 years before, but no one in mainstream science had read it. In the paper, Gregor Mendel solved the problem of heredity. Mendel worked with peas, but Bateson wasn't interested in peas. He loved chickens. He reckoned he ought to get the same sort of results, though, so he rushed out to do the experiment, and he bred a red chicken with a white chicken. And he got not pink chickens, not red and white spotted chickens. What he got was 4 white chickens. The red seemed to have disappeared. It was very bizarre. But then, just like Mendel, he bred a brother and sister from this generation. And what happened then, again, no pink, no spotted, he got 3 white and 1 red. The reds come back. And it didn't matter how many thousands of chickens he bred, it was always the same. In the second generation, he got the ratio of 3 white to 1 red. And Bateson suddenly understood that ratio and why some characters disappear and reappear. Bateson said, you shouldn't think of a chicken as being just one thing. You should think of it as being a pair of things. So this purebred white chicken here is actually a pair of bits of stuff which it's inherited, one from its mum and one from its dad. And similarly, the red chicken is a pair of bits of stuff inherited, one from its mum and one from its dad. And when these two mate together, they will pass on those things to their kids, so that this mum will pass on a bit of white and dad will pass on a bit of red. And when they have another chick, the same will happen again, and as many chicks as they have, they will pass on these bits of stuff. And now we've got a combination of red and white for each of the chicks. But there is one other critical thing, and that is that white is dominant. Whenever there's a competition, white always wins. And that means that this chick will be white because it's got white stuff in it. And so will this, and so will this, and so will this. They're all going to be white because white is dominant. However, when 2 of those breed, then we'll get some curious combinations. For example, you can get a white and a white, or you can get a white and a red, or you can get a red and a white, or you can get 2 reds, each of them equally likely. What about the colours of the chicks? Well, this one has got to be white because there's only white there. In this case, white is dominant, so again we've got a white chick. In this case, white is dominant again, we've got another white chick, but here there is no white left, and we have to have a red chick. So here, in the second generation, we're forced to have 3 white to 1 red. Bateson needed names for all these things, and indeed for the science itself. As he wrote in 1905, such a word is badly wanted, and if it were desirable to coin one, genetics might do. The term stuck, and later the inherited units were called genes. Genetics was the science of the 20th century. It started in 1900 with the rediscovery of Mendel's work and the laws of heredity. By 1999, the Human Genome Project had published the entire genetic code for the first human chromosome. An impressive achievement for the science founded and named by William Bateson. A man who lived in this back-to-back house in Bradford started off life trying to explain why radio signals fade at night, which doesn't sound very exciting. But his work led directly to an amazing discovery about the upper atmosphere. It explained how radio broadcasts can travel all the way around the world, and it helped to explain how life is possible on planet Earth. His name was Edward Appleton. As is the way with genius, people were always trying to explain why Appleton was so clever. Could it be the unusually broad head that made his birth so difficult? Despite the head, he was a good-looking lad, popular with girls, good at sport and music, and passionate about physics. During the First World War, Appleton got a job as a radio instructor, and it was radio that dominated his research when he got back. In those days, people were used to radio fading. The signal got louder and quieter, especially at night. Appleton wanted to know if this could be caused by reflections off the upper atmosphere. This is Bradford College, where at one time he was a temporary lab assistant. So I've come here to recreate the upper atmosphere so that I can repeat his crucial experiment, which involved listening very carefully to BBC Radio Bournemouth. Appleton wanted to show whether or not there really is a charged reflecting layer in the atmosphere. So he set up a simple but very cunning experiment. First of all, he raised £250, and with the money, he hired the services of BBC Radio Bournemouth. And here it is. Here is BBC Radio Bournemouth. Well, actually, this is a microwave transmitter, but we have to pretend it's Bournemouth. And then he went to Oxford, where he set up his receiver to listen to the radio signal. And if you look, I'm getting a little radio signal here. It's reading about 3 on this scale. So I'm getting some radio waves, or at least microwaves, transmitted directly from one to the other. He was interested in the reflection from this layer in the atmosphere. Now, the real one is miles up, so I brought along my own in the form of these fluorescent tubes. The real one is caused by the energy from the sun making a layer of charged particles. I'm going to get my charged particles in the tube simply by switching them on using electricity. Just see what happens to that signal when I switch on my ionosphere. It's about 3. The tubes are kicking in, up goes the signal. It's gone up to about 9. It's about 3 times as powerful. He thought about this and he realized what was going on. There are 2 signals. There's a direct signal here and there's a bounce signal that's going off the ionosphere and coming here. And of course, this path is obviously longer than the direct path. And that means that the 2 signals interfere here at this end. Let me show you what I mean. Here are 2 signals, and you'll see that the crests coincide. So we've got a nice, strong signal. But if they get out of step, you see you get a crest opposite a trough, and then these waves are cancelling one another out, and the signal fades. So it gets strong and weak, like that.
Appleton realised that this is just what would happen if the reflecting layer drifted up and down during the night.
And that's why you get this fading of the signal. So he proved that there really is a reflective layer up there, and indeed by using some clever mathematics, he was able to work out how high it is off the ground. It's actually about 60 miles or 100 kilometres.
The physics of the upper atmosphere became a new field of science, and today the interaction between the charged particles shooting out of the sun and the Earth's atmosphere is the focus of much of the space programme. But at the time there was a much more practical possibility, using the Appleton layer to bounce radio signals right round the world.
My name's Ralph, Radio Alpha Lima Papa Hotel.
So, I've come to Mike X-Ray 0 Alpha Mexico Honolulu, recognised by radio hams everywhere as Bradford College Radio, while Ralph is bouncing his signals to the corners of the globe. Or at least Huddersfield. We're trying to reflect off the sky. The hams call it the sky wave, but no luck so far.
All the way from Huddersfield. Ah, that's really exciting.
But that's ground wave, because it's too close for sky wave. Far too close.
Right. You literally can't get anything.
And if it was sky wave, it would be belting through now.
Right. So can we have another go and see what we can get?
But finally, we got a good bounced contact with Carrickfergus in Northern Ireland.
And here is the aerial. It's with this aerial that we've been able to communicate with Huddersfield and indeed with Ireland. And Ralph has communicated all the way with New Zealand. It's fantastic. Now the sun is belting down radiation, all the heat and the light that we need to drive life on Earth, but also deadly ultraviolet and particles that would kill anything if it got down to the Earth. Luckily for us, the ionosphere, which allows us to communicate by radio, also shields us from all those harmful rays. And without the ionosphere, there would be no life on Earth. My next hero was better known as a sailor than a scientist, and yet he changed the geography of the world more than anyone else in recorded history. He was the first person to lead an expedition inside the Antarctic Circle, and he disproved the existence of the mysterious southern continent. His name was James Cook.
Cook was born in a small farming village just outside Middlesbrough. He was a bright kid and a natural leader. The local squire was so impressed that he arranged his schooling and later got him a job in the fishing village of Staithes at a grocer's shop.
But James didn't enjoy being a grocer boy, so he came to Whitby and got himself apprenticed to a sea captain called John Walker. John Walker made his living by transporting coal from Newcastle down the North Sea to London. It was tremendous training for the young seamen because the North Sea is very rough and navigation was very difficult on the treacherous east coast. James Cook slept in this very attic, along with up to 16 other grubby young apprentices. And every evening he'd sit in the corner, hello Jim, sweating away over his algebra, his spherical trigonometry, and his astronomy. All of these things vital for navigation. During the winter, the apprentices used to repair and refit the ships, and the one they liked best for transporting coal was a flat-bottomed barge known as a Whitby cat. After only 9 years at sea, James Cook was offered command of his own vessel, but for some mysterious reason he decided not to take it up, and instead he joined the Navy as an able seaman to do his bit for king and country.
In 1769, Venus was due to pass in front of the Sun, a rare event that can be used to measure the distance of the Sun. The Royal Society decided to send astronomers to the Pacific to record the event. The Navy agreed to take them if one of their officers was in charge of the boat. Cook was chosen as commander, and the Whitby-built HM bark Endeavour was acquired and fitted out. The Endeavour set sail from Plymouth on the 26th of August 1768 with 94 passengers, including scientists, artists and their servants. When he set sail in the Endeavour, Captain Cook received 2 sets of sealed instructions. The first told him to convey the gentlemen from the Royal Society to Tahiti so that they could observe the transit of Venus. The second set ordered him to proceed south below 40 degrees of latitude to look for the fabled southern continent, Terra Australis Incognita. But to find the southern continent, or anything else, you had to know where on earth you were. And one reason they chose Cook was his great skill in navigation. I wanted to get a feel for what Cook had to do. In the 18th century, the simplest form of navigation was dead reckoning. And basically for that they used 2 things. They used the ship's log and the compass. Now, here is the ship's log. This is actually it. It's a bit of wood with a bit of lead on it, so it will float in the water with the lead down and it'll form a solid block in the water and keep its position. And that's attached to a piece of rope here, and when I chuck this out, it'll pull rope out of the back. And what I have to do is to see how much rope it pulls out. And it's measured in knots. Right, I'm going to chuck it out now. It's in the water, and I count for 28 seconds, as measured by my egg timer here. That's 1 knot has gone. And it's running through, and we're coming up. There, 28 seconds has gone, and I've just passed the 2nd knot. If you look at this, here's the 2nd knot has just gone through my hands, so we're doing just over 2 knots. Because it's 2 knots in 28 seconds. The knots were 47¼ feet apart. I've no idea why they chose 47¼ feet in 28 seconds, but that's what they did. And if you multiply it up, that comes to nautical miles per hour. If you also held a steady course and knew your direction from the compass, you could plot on a chart where you had been during the last hour, say 2 knots north. If you kept on doing this, you would in theory always know your position. But any inaccuracies would add up over time, so they also used the sun to fix their position every day at noon. Cook's most important piece of apparatus was his sextant, and this is my sextant. And you can see that it's got a scale along the bottom measured in degrees, and it's got a peephole here to look through, and a mirror there, which is attached to this arm, so it swivels. And what you do with this is you make sure it's horizontal. I look through my peephole and I move the pointer until I can see the sun reflected in the 2 mirrors, the one here and the one on the pointer. And it's obviously very tricky doing this in a rough sea, but this was what Cook had to do every hour when he could. So I point the sextant at the horizon and adjust the angle of the mirror until it looks as if the sun is exactly level with the horizon. Okay, that's it. I'm horizontal, I can see the sun in the 2 mirrors. And the pointer is at 14 degrees here. So that means the sun is 14 degrees above the horizon. Now Cook would do this measurement every hour on the hour and watch the sun getting higher and higher in the sky. When it got to its highest point, he knew that that was local noon. And then, of course, it would start going down. And it was even better than that, because he knew that the height of the sun above the horizon at noon gave him his latitude. That is how far up or down the world he was. Working out where on Earth you are is quite tricky. The up and down bit, the latitude, isn't so hard, but the side-to-side bit, the longitude, is much harder because the Earth is rotating. What you need is a really good clock set to Greenwich time. The idea is that when the sun is overhead at your noon, you look at the clock and find out how many hours behind Greenwich you are. Because the Earth rotates at a constant 15 degrees an hour, you can then work out how many degrees west of Greenwich you are. But in those days, there weren't any good enough mechanical clocks. But the astronomers pointed out there's a perfectly good clock in the sky. It's called the moon. So what they did was to work out the angle between the sun and the moon, and they published tables of the angle between the sun and the moon every 3 hours for the entire year. So if you're stuck out there in the Atlantic, all you need to do is take a sight of the sun, a sight of the moon, measure the angle between them, and you know what time it is at Greenwich, as long as it's not cloudy. Eventually, John Harrison, the carpenter and clockmaker from Humberside, did make an accurate marine chronometer, and Cook carried it on his third voyage. Many people believed in a southern continent. The idea came from the Greeks, including Claudius Ptolemy, who showed it on his map. He said there must be a big continent to balance the ones they knew about and stop the world from tipping over. The southern continent was supposed to be a place of great riches, and it was hoped that Cook would pinpoint it for Britain. Cook and his companions came back to England on the 13th of July, 1771, after landing on 40 islands that had never been discovered before. What's more, they brought back 17,000 previously unknown plants. But even with that lot, Cook wasn't satisfied. He suggested they should go on another voyage. They should sail as far south as possible and then sail round the world. In that way, they'd be bound to find this mysterious southern continent. Even today, these would be epic voyages. In Cook's time, they were nothing short of heroic. Cook proved to be much more than a great explorer. Although he didn't invent new navigational techniques, he used them together in ways that made his navigation superbly accurate, and his maps stood the test of time. His attitude to the native peoples they met was much more respectful than was usual. He used local names for places and traded rather than taking booty by force. Trained observers and artists meant that the information that they brought back was detailed and believable, and in Cook, the scientists had a captain sympathetic to their work. Cook circumnavigated the globe below 40 degrees latitude. He crossed the Antarctic Circle twice more. There was no southern continent. The first person to see the geography of the world as we have it today was Captain James Cook. I'm sorry, that's all the heroes from Yorkshire. See you next time. If you can light a fire with a lens made of ice, write and tell me about it. And more important, send me some evidence, a photo or better still a video, to Local Heroes, Post Office Box 267, Leeds, LS7 2BE. And you'll find details on the Local Heroes website.
And don't forget the island challenges that await the abandoned scientists on Friday night. Rough Science here on BBC 2 at 7:30.